Hi, my name is Toby Wakefield-Carl, and today we're going to be looking at another practice problem from the 2019 FRQ number 3 for Calculus AB. Alright, so as we can see, we're going to just go through identifying the type and what we're going to be doing with the problem. So as you can see here clearly, we're given a graph, so this is obviously a graph problem. And what you notice about this graph, and as will be with a lot of the graphs that they'll give you, it'll be actually geometric. So if you can see, we have two straight lines here followed by a semicircle. And this one, the radius is going to be 3. We have this quarter circle here, and then we can make the triangles using the straight lines over here. And so what we're going to be asked to do with these types of problems, I'm probably going to be asked to calculate the area at some point. And so with these types of problems, you don't have to use any integration or anything to calculate the area. You can just use a simple geometry, form little triangles here and there, and then form this area over here would be the square minus the quarter of a circle right there. And so you can just calculate the area that way. Another thing we also might be asked to do is evaluate the limits at certain points on the graph. And if the graph is not geometric, they'll give you equations for all the lines so that you can use integration and stuff like that to calculate the area. And then so typically everything above the x-axis will be positive when you're calculating the area, and below it will be negative. The only exception to that is when they switch the limits of integration. So if they go from least to greatest all the time, then you can stay top is positive and bottom is negative. But if they switch it and they go from, say, greatest to least, then you might have to switch around which one is negative and which one is positive. Alright, so let's just go right into the first one. Alright, so part A asks us to calculate the value of this integral from -6 to -2 of our function. And we're given that the integral from -6 to 5 of this function is 7. So if we go back to our chart right here, we see that we're only giving the integral from -2 to 5. And so when it's asking us to calculate from all the way to -6, we don't have any graph that goes all the way to -6. We only have from -2 to 5. And then since we're asked to calculate the entire thing, we can use the internal addition rule. And so it just states that we can break this integral up. So instead of saying from -6 to 5, we can then say from -6 to -2, which is what we don't see on our graph, and then we can calculate the rest from -2 to 5, which is what we have on our graph, and we can just add those together and it'll give us the total amount. And so we just do it like this. So this side they give us that this whole integral equals 7, and then so we're just going to calculate this integral here, and this 2 plus the 9 minus 9 pi over 4. If we go back to the graph, this comes from, so the area underneath the curve of all of this, of the two lines, that comes out to 2 using the triangles, using geometric area and stuff. And then the 9 minus the 9 pi over 4, it comes from this square minus the semicircle there. Alright, so going back, we just do some more simplifying. And so we move everything up to the right side, and we get the area of this integral. The solution to this integral is 7 minus 11 minus 9 pi over 4, which is coming from this. And then we get our answer. The total area will be 9 pi over 4 minus 4 for the entire integral. And part C of this question is asking us, the function g is given by this integral here. And as we notice here, we see that f of t dt. And so we want to get rid of that, and just by doing that, so we can take the derivative of both sides, and I'll get rid of it. So we're just saying the g prime of x equals f of x. And so we want to see where f of x equals 0 to find our limits of integration. And so these are the points where f of x equals 0. And from there, we can go into our chart, test different things to see where the g is the max, and we see here that -1 is our greatest point here before it goes negative, and it goes to 5. And so we come to our conclusion that on this integral, that the greatest amount is at g equals 5 at 11 minus 9 pi over 4.